Hello, welcome to part 2 of our Introduction to R video lecture. In the first part, I introduced you to RStudio and R and to the 4 panels that you can see in the RStudio window. Now we'll go on. So I showed you before that you can use R to send commands to the console and execute them and then get the answers. Now one thing we want to do is save these commands so we can use them later on. So we can save the answer of 3 plus 3, but in the end we will also save commands like your data file or a graph object. We can do that using the assign operator. This is arrow sign here. It consists of an arrow sign to the left and a minus symbol. Whatever you write on the left of that, some name, doesn't matter, is the name of the object that we're saving, and whatever is on the right of this is the value that we're assigning to this object. I can execute this, and now I have an object called SOMNAME, that in this case is 2. You can read this assign operator as whatever is on the right becomes whatever is on the left. Now, alternatively, you might see people use an equal sign, which is used in other programming languages like C++. It is almost the same. You can basically use them interchangeably. There's only a small difference with the equal sign, is that it doesn't allow for object assignment in functions or in function arguments. But it's a small detail that nobody really cares about. I would still suggest that you use this arrow sign rather than the equal sign for 2 reasons. Mainly because it's not ambitious. It's very clear with this arrow sign that whatever's on the right of the arrow sign becomes whatever's on the left becomes whatever's on the right. So this is assigned to whatever's on the left. With the equal sign, that's less clear. Because now I have to realize that this goes to the left and not the other way around. There's also a right hand operator, but don't actually ever use that because everybody really hates that. Another argument for using the arrow sign is that in the R community it's generally more accepted to use the arrow sign rather than the equal sign. And people that like the arrow sign are usually a bit more hardcore than the people that like the equal sign. So you make more friends by using the arrow sign. An object in R can be anything. And any R expression that's not stored in the object are printed to the console. So now we can see, because I don't store the value of this object, it's printed. But because I do store the value here, nothing is printed. And that's why this gave me an answer already, where this 1 plus 1 is not printed immediately. I have to request it then what this value is from the console. Okay, so for example, I can assign a number 1 to an object called A, or B, or C, or anything. And now I can ask R what is A, and R will tell me A is 1. Now I can use this object, so I can compute things with this object. I can use it again. I can say A is 1, then I can say A plus 1, what is that? Well, that's 2, because A is 1 in this case. All the objects that you have are listed in the workspace. So in this case here, I can see that I have an object called A, that is 1, and I have an object called SOMNAME, that is 2. Now when you quit R, it might ask you if you want to save your objects in your workspace. I can highly recommend that you never do this. You want to write a script that creates all your objects, and every time you want to start R, you want to start R from an empty environment, and then run your script to get your objects back. If you don't do that, you might use an object in your environment that you forgot about how to make it, and then you send your script to someone else, and then that person cannot reproduce your code because that person does not have that object. You can use any name you want. One thing that's important is that objects are case sensitive. So object with a capital O, and object in all capitals are very different objects. It's generally recommended to use informative object names. For example, sample size, raw data, and males, rather than X, Y, P, T. So that later on, if you read about your codes again, you can understand what you intended this object to be. Now, one trick I often use is to use camel case, where you start your object with lowercase letters, but then start every second word with a capital letter, like sample size, or raw data, or end males. Now, R makes use of something called a working directory to know where you are working in and where to look for files that you might want to read, such as your data files. If you go to R, you can see your current working directory here. ~/desktop/ in my case, because I just set it that way, using the setwd function, which stands for set working directory. And you can see here before that I tried to set it to some different folder, so that's how you can change the working directory. This tilde here is shorthand for your home folder. So if your name is Sascha Abskamp, that would be /users/Sascha Abskamp/ on a Mac computer, but that might be different on a Windows computer. One thing you can do, the very easy way to set your working directory, is go to Session, Set Working Directory, to Source File Location. Now it sets it to desktop because I saved this script on the desktop. That's the way I can recommend you to always set your working directory, just to set it in the same script location as the script that you saved it in. You make a folder, you put your script in there, and then any data you want to read, you want to put in the same folder, and then you simply set your working directory with set source file location. If you want to know your current working directory, you can ask for getwd to get the current working directory. This is to show how you can set the working directory to the source file location. Okay, this is the end of part 2. In the next part, I will talk about more advanced data structures than numbers, such as vectors or character strings.